congruent. So opposite angles being congruent would tell us that 72 and that 3e must be the same size. So we'll put little tick marks on there. All right, so then we can get our e by going 3e equals 72. So e is just going to equal 24. What's G? You Shana?
108.
How'd you get 108?
Because 72 and G are supplementary.
Yeah. 72 and G must be supplementary, so G has to be 108 degrees. So we'll have G equals 108 degrees. All right, then let's look at the other two angles that must be congruent. These two must be congruent. E plus F and G must be congruent. So we can write something like E plus F has to equal G. But I already know what E equals, so we'll have 24 plus that F equals G, which is 108. 108 minus 24 is F equals 84, so your correct answer should have been B. B as in boy, I got that one right. Or B as in boy, I should have picked B because I picked the wrong answer. All right, questions on that one? Cool. Questions from the homework? Yeah. 15. Make sure I got the right one up here. I think we just had that question in the other class. Let's just go over it. All right, 15. I think I took a picture of it for the other class too, so we should be all set. Maybe. There you are. All right. So for all of these problems, they started out by stating that all these lines are parallel. Right, Tori? I said right? You just keep talking to Cece. Oh, okay. All right. So it says that all these lines are parallel. And it also gives us that EF, FG, and GH are congruent. But since that's true, we know that AB, BC, and CD are all congruent. That was that one theorem we had, that if you have parallel lines and one transversal is cut into congruent segments, any transversal is going to be cut in congruent segments as well. Then we look down. It says that AB equals 12. Well, if AB equals 12, that means BC equals 12, and DC also equals 12. Well, here they say that BC equals 2x plus 3y. But BC also equals 12. So we're just going to say 2x plus 3y equals 12. Well, we can't do anything with that because there's two variables. You need a second equation. So we keep reading. It says that BD equals 8x. B to D is 8x. What's the difference? What's the distance from B to D? Did I read that right? Yeah. What's the distance from B to D? $24. Oh, I shouldn't say 8D. I should say 8x. So we can now say 8x equals 24. So x would equal 3, which you'd plug in to your x to find your y. Does that all make sense? Did I lose you anywhere? All right.
What about 17?
What about 17? All right, 17 says a segment joins the midpoints of two sides of a triangle. Find the values of x and y. So it says that those two things are midpoints. So it said this is a midpoint, and that's a midpoint. So because these are midpoints, this is parallel. We have that one theorem that says it's parallel. And this is going to be twice as large. So if this is 7, this has to be 14. So 5x minus 3y must equal 14, which I have here. And then since this is a midpoint, this segment must be the same length as that segment. So we should also have a 3x minus y equals 8 because those two things are congruent. Then I just use elimination to solve for either variable. Either elimination or substitution, however you...
Do you always have to use elimination?
You do not always have to use elimination. I usually use elimination, right? We've seen me do it over and over. I like elimination because I can do it more so in my head. But if you want to use substitution, awesome. Just make sure you keep the steps straight. Or you could graph it. That'd be a horrible way to do it, but it's possible. All right, other questions? Questions going once? Twice? Yes. Whew, just under the wire. Yeah. 9. You just waiting to see if someone else asked it first? Okay. Yeah, you have the same question, right? I was going to go over either way. All right, so number 9. So I think you just missed it in the answer key. But number 9. Number 9, we should have came up with D and F, and let's talk about why. First of all, we should agree that F is a midpoint, right? Because they actually tell me it's a midpoint. They give me those two little symbols on either side saying that's congruent to that. So F has to be a midpoint. Now we have a parallel line. Can a parallel line go through one midpoint of a triangle? No, it can't. It has to go through 2 because we have that theorem that says if you have a parallel line to that third side, if this is a midpoint, D must be a midpoint. So your midpoints are F and D because you have a parallel line, you have to have 2 midpoints. Yes? Just touch. So you're saying like here? That's just touching? Yep. I'm picturing these things as being lines that go on forever, so it does go through, but yeah, they just have to touch. So parallel lines have to go through 2 midpoints or no midpoints. Yes?
So midpoints are always going to come in like even sets?
Yes. If there's a parallel line. Because if I draw a line like this, that's not a midpoint. Can you kind of picture that? So if you have a parallel line, it's going to come in either 0 midpoints or 2 midpoints. Let me rephrase that. Because there are times where E would also be a midpoint. But when you're dealing with a parallel line, either it's going to be both of them are midpoints, or neither of them are midpoints, if there's a parallel line. Okay? Just re-examine that theorem that says if a parallel line goes through a midpoint, then the other side is a midpoint as well. All right, does that make sense though? Okay, good. Good? Bad? Somewhere in between? Yeah, we just did that yesterday. You should have a drawing of it.
Wait, so for number 8, when would it be D?
Just a second, I'm still answering hers. Just 1 second. So we had a line that contains a midpoint of one side of a triangle and is parallel to another passes through the midpoint of the third side. So if this is a midpoint, then that has to be a midpoint because you have parallel lines. Okay? Yeah, yeah.
So for number 8, would it be D plus E?
It would be D and E. Yes, you are correct because D is a given midpoint. Since it's a parallel line, E must also be a midpoint. For 7, it should be D and E. We have no parallel lines, so you just have to go with the fact that we have X and Y on the other side. That automatically makes them midpoints. But F is between Z and Z plus 1, so those are 2 different lengths. It'd be kind of like 5 and 6. All right, other questions? All right. Then we'll go through today's lessons, which are special parallelograms. Don't forget what it means to be a parallelogram because those still apply to all of these. We're just adding something to it. So the first thing we're going to talk about is a rectangle. The definition of a rectangle is a quadrilateral with 4 right angles. I'm not talking about the sides, not talking about anything else. The definition is it has 4 right angles. Why is a rectangle a parallelogram? Yes?
Because opposite angles are congruent.
Opposite angles are congruent, which would be what theorem?
Theorem 5 2.
Not 2, because we're proving it's parallel. Maybe one of those converses.
Okay, so
5-6. Yep. Because theorem 5-6 says if opposite angles are congruent, then it's a parallelogram. So all rectangles have to be parallelograms, which means anything that applies to a parallelogram applies to a rectangle. So that means opposite sides are congruent, opposite sides are parallel, and diagonals bisect each other. So those first 3 theorems on your theorem sheet all apply to your rectangle. If you're not sure what I'm talking about, look at theorem 1, theorem 2, theorem 3. All 3 of those apply to rectangles. But since it's a special parallelogram, it has special theorems that go along with it. And those are theorem 512 and 516, which I'm just going to go to your sheet so we can draw pictures on it. So let's talk about 512. Yeah? You get to use those theorem sheets on your... But the students that do the best on it are the ones that know all of them, and they just kind of have to use it for a quick reference. All right, the diagonals of a rectangle are congruent. The diagonals of a rectangle are congruent. That's theorem 512. So if we have a rectangle and we draw ourselves some diagonals, maybe we call this A, B, C, D. And in order to make it a rectangle, you do have to have 4 right angles. There we go. I have a rectangle, and I have diagonals. According to this theorem, AC is congruent to BD. Cece.
If the diagonal lines, the diagonal angles.
The diagonal lines. There really isn't anything called the diagonal angle. A diagonal is a line that goes diagonally from. If I was going to talk about these angles, I would say the angles formed by the diagonal. All right, but that leads us to one more important part I'd probably want to put in this diagram. Since this is a parallelogram and my diagonals are congruent, the diagonals of a parallelogram bisect each other. So the really cool thing about a rectangle is all 4 of these segments will be the exact same size. So AC would be congruent to BD, and all of these segments will also be congruent. So maybe I'll put a little M in there and say something like and I'll write down below BM is congruent to MD, is congruent to AM, is congruent to MC. Yeah, great.
Could you, like, in a proof, use theorem 512 to prove that it's a rectangle if all 4 of those sides are, like, congruent?
That your diagonals are congruent?
Yeah.
It's not going to prove it's a rectangle per se. But yes. Yeah, we don't really have a converse to that. Because it could be a rhombus too. Because the only thing that makes it a rectangle is a 90 degrees. It's just with it, then we know that's a fact too. I would buy it though. If you sold that to me on a proof, I'd buy it. Okay, the other thing that goes with a rectangle is theorem 516. So go down to 516. 516 says if you have a parallelogram If an angle of a parallelogram is a right angle, then you have a rectangle. So you have to be given a parallelogram. Parallelogram, remember the definition is just opposite sides are parallel. Then it says you just need one right angle. If you are given that, a parallelogram with one right angle, then it has to be a rectangle. But if you think about it, it has to make sense. It's a parallelogram. So opposite angles have to be congruent. So your top left angle would be 90 degrees. Consecutive angles have to be supplementary, so that has to add up to 180. So your bottom left has to be 90, and your top right also has to be 90. By including just one angle, you know the other three have to be 90 degrees as well. So that's where this proof comes from, or this theorem comes from. If you have a parallelogram with one right angle, you have a rectangle with all the glory that comes with it. And that is diagonals are congruent. All right, just like our drawing of a rectangle, we're going to apply this to a right angle and then get us theorem 515. So if you look at the rectangle I have drawn here, it's a rectangle because all four angles are right angles, which means our diagonals are all congruent. And since it's a parallelogram, they all bisect each other, so all these segments are congruent. Well, if you pull a right triangle out, you're going to notice that if this is a midpoint, all three of these segments are congruent. Real quick, let's reach back to our knowledge of triangles. What is that line called if it goes from a vertex to a midpoint on the opposite side? Hamza?
Median.
A median. Yep, that's a median. The line's a median, and the point is a midpoint. So in short, if you have a median of a right triangle going towards the hypotenuse is your long side of a right triangle, then all three of these segments are congruent. Almost everyone in here will forget this, because it just keeps kind of coming up. And it looks really easy when you just have a right triangle, but remember when I give you like those big drawings and you have to like see like a right triangle pulled out of it, that's when you really get stuck on it. But just remember, right triangle, midpoint, creates those three congruent segments. So that's theorem 515. Let's go ahead and do these examples. So it says angle KAP is a right angle, so let's go ahead and make it a right angle. So I'll put that little box on it to say it's 90 degrees. And AM is a median. Since AM is a median, M is a midpoint. M is a midpoint, so all three of those segments are congruent to each other. So if MA equals T, what is the length of KP? Once again, if MA equals T, what is the length of KP? Yeah, it's 2T, which is really fun to say, 2T. I don't know, maybe that's just me. I'm just weird. All right. Our second problem has the same setup. I have a right triangle. All three of those sections are congruent. So maybe I'll put the right angle. It says the measure of angle K equals 40 degrees. And then it says, what is the measure of KAM? It's a little tougher, but you have all the information you need. Did you give up?
Wait, I thought I remember the drawing.
You want to take a shot at it?
Is it 40?
It is 40. Do you know why it's 40?
Because it's this isosceles.
Because it's an isosceles triangle. I purposely didn't write it on there, but if we look at MK is congruent to MA, that's an isosceles triangle. So that means KAM must be 40 degrees. Hamza.
So I don't really get in this theorem when it says, like the hypotenuse of a right triangle is equidistant to the three vertices. What does that mean?
Equidistant means it's the same distance. So this is congruent to that is congruent to that.
Okay.
That's what equidistance means. It means you can put little tick marks on each of those lines. Yeah, Cam.
Wouldn't it be 45?
It would not be 45 because all I'm saying is this is an isosceles triangle because these two sides are congruent. And with an isosceles triangle, the base angles are congruent. So those both would be 40 degrees.
Do they have to add up to 80?
What was that?
Do they have to add up to 80?
No, they just have to be the same measure.
So does it have to be 40 degrees?
So this has to be 40 because this one's 40. So on an isosceles triangle,
Oh, okay. Oh, it says m is equal to.
yeah, so they gave us that. On any isosceles triangle that you have, let's make that isosceles. Whatever I name that one, call it 33 degrees. This one has to be 33 degrees. And then we can get that third one because they have to add to 180. So in fact, knowing this is 40 and this is 40, what's this measure here? What's that measure of KMA? Yeah, 100. So what would the measure of PMA be? Yeah, 80. And then we could get these two as well, right? Those both would be 50 if you did it. All right, let's do the next one. KP, again, is a right angle. And it says that AM is a median, once again. And it says that MP is 6.5. So what is MA if MP is 6.5? Grant? 6.5. So my advice to you is if you see a midpoint on a triangle, make your marks right off the bat, then you don't forget stuff.
The midpoint on the hypotenuse, right?
Midpoint of the hypotenuse, yep. Sorry, I should have specified that. Yeah.
So that median line doesn't split the angle in half.
It does not split the angle in half, correct. All it does is it splits the line in half, and then we can do that one. Yep. Great question. Ooh, a triangle. All right, rhombus. We just have two more. A rhombus. A rhombus is a quadrilateral. It's got four sides, so it must be a quadrilateral. With four congruent sides. Therefore, every rhombus is a parallelogram. Why? Why, based on the definition, is it a parallelogram? Yeah. Because the opposite sides are congruent. What theorem says that if opposite sides of a quadrilateral are congruent, then you have a parallelogram? Isabel?
Theorem 5.4.
Theorem 5.4. And if you're not sure of that, look it up. Don't rest on the laurels of other people. Every time we talk about a proof or a theorem, you should look it up. Right, Sam?
Yep.
As you're not doing any of that. But as long as you get your homework done. All right. Theorem 5.13. The diagonals of a rhombus are perpendicular. Did I say anything about the diagonals being congruent? No. That only is a rectangle. A rectangle, your diagonals are congruent. With a rhombus, your diagonals are perpendicular to each other. So a drawing of that would look something like that, where I put a 90-degree symbol on there. Here's kind of my advice to you on this drawing. What I'm going to do is I'm going to put 2 tick marks on my vertical one and 3 tick marks on this one, showing that it still bisects because it's a parallelogram, but these are not the same length. Kind of like a rectangle, we could put the same mark on all 4 of them. On this one, our horizontal one, we could put 3 tick marks on. On this one, we could put 2 because it bisects, but we don't know all 4 of them are congruent. All right, theorem 5.14, each diagonal of a rhombus bisects 2 angles of a rhombus. So let's draw one diagonal for right now. I'm going to draw one diagonal. That bisects 2 angles of your rhombus. So what you can then do is you can say all 4 of those angles are congruent if it's a rhombus. If it's a rhombus, all 4 of those angles are congruent. Well, let's drop down our vertical one. Now we could put 2 tick marks because all 4 of those are congruent. Are all 8 congruent? No. Only the ones that are across from each other are congruent. And this only deals with a rhombus. Just a rhombus. So not all parallelograms do this, just a rhombus. So think about this. In a rhombus, your diagonals bisect angles. They bisect each other's lines, and they're 90 degrees. So you get a lot out of the diagonals of a rhombus. All right, finally, theorem 517. If 2 consecutive sides of a parallelogram are congruent, then the parallelogram is a rhombus. So first of all, it must be a parallelogram, so you have to put your parallel lines. And then we just need 2 consecutive ones. Yeah?
So this proves that it's a rhombus.
This would prove it's a rhombus. So let's say you're given a proof and it says you have a parallelogram. And 2 consecutive sides, like this side and that side, are consecutive. Then it has to be a rhombus. So if you're given a parallelogram, 2 consecutive sides being congruent, you know it has to be a rhombus. And kind of use common sense on this. If this is a parallelogram, opposite sides have to be congruent by theorem 5.1. So these 2 sides would have to be congruent. These 2 sides would have to be congruent. So all 4 of them would have to be congruent, just based upon it being a parallelogram. Okay?
So it says like 2 consecutive sides. Does that mean like 2 sides at once?
Yeah, basically 2 lines that aren't parallel. So let me erase. So those could be our 2 consecutives. These could be our 2 consecutives. The only thing they can't be is across from each other. So those would not be consecutive if they're across. All right, questions on either one of those 3? All right, we just have one more super guy. That is a square. A square is everything. It's a parallelogram, it's a rectangle, and it's also a rhombus. So every theorem that works for a parallelogram works for a square. Every theorem that works for a rectangle works for a square. Everything that works for a rhombus works for a square. So real quick, a rectangle has 4 parallelograms with 4 right angles. And we also know about a parallelogram. What did we just learn about a parallelogram today about the diagonals? Yeah. They bisect, but something more important. They are congruent. So with a rectangle, diagonals are congruent. But that means the diagonals of a square are also congruent. For a rhombus, we have a parallelogram with 4 congruent sides. But with a rhombus, we knew 2 things about its diagonals, really. The diagonals bisected angles. And we also learned that diagonals are perpendicular. Which means a square's diagonals bisect the angles, and a square's diagonals are perpendicular. Yeah?
Can you draw this picture on the box frame that
Sure. I don't see why not. But realistically, you just have to recognize that a square is everything. Everything you can say about a parallelogram, you can say about a square. Anything you say about a parallelogram, you can say about a rectangle. Anything you can say about a parallelogram, you can say about a rhombus. The square adds the fact that anything you can say about a rectangle, you can say about a square. Anything you can say about a rhombus, you can say about a square as well. So anytime you're trying to prove anything about a rectangle, you're actually looking at your parallelogram, rectangle, and your rhombus theorems. You can look at all three of them to prove something as a square. Questions on that? All right, then I want you to look at your homework really quick. Look at your homework so you don't struggle through this. 1 through 10.
Is the diagonals of a rectangle, are they perpendicular or no?
Did we have a theorem that says that? Then no. No, only a rhombus. Has to be a rhombus or a square. I said rhombus or a square, they are perpendicular. Yep, if there's no theorem, it's not true. Okay. All right, look through 1 through 10. It's a giant grid of where you put x's. So you are just putting a check mark if it has to be true. So look at the first one. Number 1 says opposite sides are parallel. Is that true for every parallelogram?
Yeah.
Yeah, so you're going to put a little check mark down there. What was that? It also works for a square too, yeah. Also a rectangle. Are opposite sides of a rectangle congruent? Yeah. So you're going to actually have a check mark in all 4 of the boxes for that first one. Because a parallelogram is opposite sides parallel. A rectangle is a parallelogram, so they must be parallel, congruent. Rhombus, they must be parallel, and a square must be parallel. Yeah, go ahead.
So if we check off parallelogram, don't we check off all 4?
Maybe. All right. That'll be at your own discretion. All right. Let's go all the way down to 6. Do the diagonals of a parallelogram have to be congruent? No, so you're not going to put a check mark on there. Which one has diagonals being congruent, Sam?
Rhombus.
A rhombus and a
Square.
square. So those would be the only 2 that you put check marks on.
What about rectangle?
Are the yeah, it should be rectangle and square, not rhombus. It should be rectangle and square on that one, not a rhombus. So those are the ones that have to be. Because the definition, one of our theorems for a rectangle says that diagonals are congruent. So you put a check mark on that one, and then you put a check mark on your square because the square is a rectangle.
Would it be the same too for 7?
For 7, no. Because a rectangle's diagonals do not have to be perpendicular. There is a theorem, though. We just learned that a specific shape has perpendicular diagonals. All right. So just so you know what you're checking off. It has to be. All right. The rest of the time is yours to work. Yes, yeah.
That's a question.
Oh, yeah.
Rectangles are parallel. So does everyone have mark on the parallel? I did it 2 different ways.
Okay.
I made
You are correct.
I did. That just same order.
Yeah.
Not every other one.
Number 19 can be a decimal, or is a decimal, I should say, or a fraction. Yeah, make sure you're not just trying to finish your homework while I'm teaching. I'm saying important stuff, whether you think you know it or not. We're going over proofs and stuff. Yes.
No, I don't think it's a rhombus, but it's a parallelogram rectangle square.
It's over 11, it's minus 25. And then 2 is 25.
Say that again, I'm sorry. Yeah, that's what you're doing. So you're reading what it says, and then you're just filling it, just like that.
And so it's 3 between 5
I don't know, I don't have it in front of me. To see if it matches the drawing, you should have it in your box. So if you go to our rhombus.
Otherwise, we're gonna get homework completely wrong.
So you can look at all the opposite sides. So 3 probably isn't.
Yeah, parallelogram.
Because 1 and 2 are right there, so those 2 are congruent.
Then how are
So did you guys check off rhombus for number 3?
I just have squared, but all of them.
Yeah.
So you have a 90-degree angle.
5 would be 9.
What's the difference between a rhombus and a parallel?
5 would be 90, yeah.
This also
And all 4 of those would be 90.
Opposite angles.
Just
And then
oh.
base 3 has to be.
Yep.
Oh,
Wait, isn't, oh, because
Oh,
opposite angles.
it's 4 right angles, so all of them are technically
guess I can in the triangle.
Yeah, so then it's both again.
Could you please write them individually? I wouldn't take any points off on a test, but it makes it easier for me to check it when I'm walking past.
I think it's all, it's 4 of them that hold in row.
Is the only difference between a rhombus and a parallelogram is that a rhombus has 4 congruent sides. Is that
Mhm.
it?
Which leads us to all the school diagonal rules. Well, hang on. A rhombus is a parallelogram, right?
Yeah.
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 Okay. I thought you said the difference between a parallelogram and a rhombus.
Yeah, I did say that.
Yeah, but you get why they're still the same thing. It's just one's very specific.
A type of
Parallelogram. It's a type of parallelogram. Yeah. So I feel like some people lose the fact that they're parallelograms and they still apply all the same facts to them.
Yeah, yeah.
Sorry. Yeah. Angle 1 and angle 3? Probably not. Because angle 1 and angle 2 are
You
equal to
should
each
want
other.
all 4 for number 4.
And then we know this is 90 degrees in here, right?
So when I do that plus that equals 180?
Plus 90, right?
Oh,
Because we have 2 plus 3 plus 90 degrees would equal 180. So you have to have that 90 degrees in there. That should be enough information to get what you need.